Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Naufal bin Nohan, and today I will do a demo simulation for my final year project, in which is in the title of Appliance Scheduling for Smart Home System using Particle Swarm Optimization. So I am under supervised by Dr. Siti Mahirah binti Hussein. So in this video, I will demo my simulation, which is the particle swarm optimization. So in this script, this is the particle swarm optimization coding in MATLAB software. So first of all, what we do is we set the size of decision matrix, which is 1 to 1 column, and then we set the lower bounds of the variables and the upper bounds of variables. So next we continue with the PSO parameters value. So this is the initiation. So we need to set the PSO optimization parameters. So we can set the number of iteration. We can set the population size, the initial weight, and also the acceleration factor. So next is the PSO, uh, the initialization, which is we need to make a like a template for the velocity, the variable that we want, the cost, and then the particle best for the radius and the cost. So first of all, we create the population array, and then we initialize the global best. So our agent fitness is the to generate the random solution, which is the switching time for our appliance scheduling. So after we do a random time, we initialize the velocity, and then we try to update the personal best based on the given switching time, and then we need to update the global best from the personal best. Okay, let's continue. And then this is the main loop of the PSO. So the iteration starts with from 1 until the max number of iterations. So in this case is 50. So after that we try to update the velocity using this formula. We try to apply the velocity limits, and we update the positions based on the particle velocity. And then we continue with to apply the lower and upper bound limits. And then the lastly is evaluations from the particle cost. And then we update the personal best, we update the global best, and lastly we display the iteration formation so that we can get the best optimize switching time for our next coding, which is to schedule our appliances. So as you can see from here, we get the switching time of 18. Okay, next we continue with our coding for plan scheduling. So first of all, we load the data from our PSO. So as you can see, we have 5 types of appliances. So the first one is the aircon. Firstly we need to set a day for 24 hours. Before we continue, let me give you an insight for our electrical tariff. As you can see here, this is our electricity tariff from uh, 9 p.m. until 7 a.m. Our for 9 p.m. until 8 a.m. our tariff will be on 3 cents, which is this is called the low peak periods. And at this period 9 a.m. until 11 a.m., this is called the mid period. And this is the part in the evening, which is the medium periods. And we have the high peak period, which is uh, the highest cost, which is between 12 p.m. until 5 p.m., which is about 10 cents per watt hour. So this is our time of use tariff. So continue with the our coding for appliance scheduling. So the first one is the aircon. As you can see here, we need to set the day for 24 hours. So we have 24 hours time slot. So this is the timing constraint for time preference. We show that the appliance need to work under an allowed power and the allowed time slot. So as you can see here, we have the parameters of the electricity tariff, which is the from the figure that I shared. And then this is our objective function, which is to calculate cost, which is times with the time slot. So this is the parameters that from the PSO, which is to have a random number of switchings. So as you can see here, we have the power of appliance. So for aircon, this is the 4 kilowatt, and uh, the system works is that it tries to uh, have the same amount of manual schedulings, which is in this coding they have only 7 times switching for aircon throughout the day. So they will to switching the schedule in the case of they will try to have the lower cost possible from uh, the electrical tariff. So as you can see here, if the cost function here is more than 1, and then the energy use is less than the maximum energy, so they will have a switching schedule will be 1. So in the 24 hours time slot, there will be 7 times it will be switched based on the maximum demand, and then it will helps to have a less cost compared to the manual scheduling. So continue with this is the second appliance, oven. As you can see here, the oven needs to operate 3 times, so that we have a 3 time slot for the allowed power, so that the oven will not uh, the oven will not schedule 3 times in a row, so that the user only eat like in the morning. It cannot be like that. It needs to be distributed throughout the day. So this is the random number for switching from our PSO. So this is will help uh, the oven to be scheduled distributedly, and at the same time to help reduce the cost. So continue on. This is for the desktop computer for appliances, and continue with the water heater, and lastly we have the washing machine with clothes dryer. So the constraints here are the timing constraint and the maximum demand, so that the appliance will never work at one time slot. They will never work all the time. If the appliance work in a time low only on low peak periods, then the high peak periods we have no appliance schedule. I tried to make the demand from uh, low peak periods to have a maximum demand, so that not all appliances can work in that hour. So continue with the results. So first of all, this is the comparison of electricity cost between manual scheduling and appliance scheduling. As you can see here, the general view of the manual scheduling, uh, it costs about 378.5 cents of electricity cost, while the appliance scheduling that using the PSO, we get 292.9, which is lower than the manual scheduling. So next, we try to make the for another figure. So this is the figure for electricity cost in each appliance before and after scheduling. As you can see here, the blue graph represent the before scheduling, and the brown is for the after scheduling. As you can see here, this is the air conditioner, oven, desktop computer, water heater, and cloth dryer. As you can see, only two of the optimized scheduling appliance, which is aircon and clothes washing machine, have optimized to be in smaller cost, while desktop computer and oven, the scheduling have more cost. This is due to the maximum demand that I have just told, that they the time slot for the low peak periods may have been in maximum due to the schedule for aircon. So then the oven and the desktop computer might be in work for the higher periods, but they have the lesser power consumptions, so they cost like a bit cheaper than the aircon and the washing machine. So next, I want to show you about the comparison scheduling of power consumptions from our coding. So you can see here, this is the comparison of power consumption between before and after scheduling. As you can see here from the graph, the blue graph represent the before scheduling power consumptions, and the pink is the represent the line graph for after scheduling. So as you can see here, the high peak is between 12 to 5 p.m., right? So as you can see here, the high peak, the power consumption for before scheduling, it shows that they have larger power consumptions during the high peak, and it costs them high cost, more cost compared to the after scheduling. So it works by its schedule during the low peak periods. So that's all for my demonstration for MATLAB software for appliance scheduling using particle swarm optimization. Thank you.